how do you see the next 18 months? What do you see the challenges for design engineers in this environment? Where do you see potential changes and developments, and for our community to keep an eye out for and to bear in mind when they're starting a project? The whole point of this discussion is for an experienced design engineer who is dealing with problems every day, sharing that and helping other design engineers understand what they understand about the world. Good morning, ipXchange. We're at the world famous studios again. Don't we just love the pink X? We are doing something slightly different today with our ipXperience. We're talking to Anton, and normally when we have these discussions, we're talking about we're introducing you to disruptive technology. We're introducing you to semiconductor companies, software companies who are doing different things that are going to help change your applications. They're going to bring you new technology. They're going to help you understand this whole new landscape of what's going on in the world with Edge and Edge AI. So today we're chatting to Anton, who is actually on your side of the world, because we think that it's really interesting to bring some real life experience so you can share that, understand how somebody who's doing this every day, what they're facing and how they're seeing the world. And we thought that would give a different kind of idea, a different kind of outlook. So we're introducing you to Anton. So Anton, hello, welcome. Wave,
Yeah.
please wave at me, Anton. That would be very nice. Welcome to ipXchange. Welcome to the ipXperience with our big pink X. Where are you today?
Hi everyone. Hi Guy. Thank you for inviting. I'm like at my home in Norway, so thank you for inviting.
Excellent. Tell us, Anton, about what you do in your business and what you do every day.
We were doing computer vision consulting for last 15 years. Sometimes we work with some startups like more close, like for few years, maybe like 5 years in some cases, and trying to create them all the computer vision tech, like all models, all real life environment, like production and so on. So I'm more like on this side where you need to create some algorithm and make sure that this algorithm is running on the real hardware and providing some results that's valuable for business.
Right. So your world is all about understanding how machine learning is taking place in your machine vision world. And so what changes have you seen, let's say in the last 5 years, so just before the pandemic to today, where that technologically is such a vast jump? Tell me about the changes that you've seen in those 5 years between the kind of things that you were talking about 5 years ago and the kind of things that you're talking about today.
Last 10 years, they were super fast. And each year, like from 2014, when there was a big breakthrough in neural networks, in convolutional neural networks, each year bring us a lot of new stuff. And it's hard to understand, like, this something that we get this year, because sometimes like works that were few years ago, they like light in this year and they super exciting. So mostly, of course, it's Transformers, of course, like LLMs, big language model. Today, it's maybe like more VLMs, visual language models. Of course, It's like from hardware part, it's a lot of NPU devices, but actually a lot of them, they appeared maybe like 2017, maybe a little bit late, but today it's like a lot of good, reliable devices that you can use. And of course, like all this synergy today, it's like on the next level, maybe, because all this technology like NPUs, hardware, algorithms, even robotics, like today robotics, it's fantastic in my opinion. So today we at the point where like all these technologies, they boosted us a lot. And maybe like the main breakthrough, it's some transformers, diffusion models, it's from mathematics, and some NPU chips, it's from hardware part, in my opinion.
Right. So in machine vision, even though you sort of described it as being over 10 years, but those changes are really only over the last 2 or 3 years You could even say they're really over the last 2 years, aren't they? So this is a place where what's interesting from our community's point of view is that means everybody's really starting from the same place up until about 2 years ago, because that was at the point that technological jump was made in machine vision with machine learning, and then you were talking about other types of technology that was introduced into the infrastructure, and these are all new things everybody's learning about. So the reason why we invited you to come and have this chat today is because you have real life experience of going through that change, going through that learning about transformers, going through that learning curve of machine learning, going through that whole sort of industrial vision environment. So we thought it'd be very interesting to have a chat with you to find out what are the things that you find most challenging, and what are the things that design engineers most have to look out for today when they're working in those kind of environments and those kind of applications. So could you just outline for us how the things that you see that are going on in the designs as a consultant, the designs that you're seeing going on, and the issues that you see, and then maybe some of the, not obvious, but some of the mistakes that you see happening every day and ways that you think that people should be dealing with them.
Yeah, of course. Like, in my opinion, when we're at the point where a lot of technology meet each other, it's like super important to understand like a little bit stuff from different worlds. And when you creating some device like that providing computer vision on the edge, you need to keep in mind not only like electrical part, financial part, but also and some algorithms. And one of important mistake that a lot of people doing, they don't check in that for their device they can actually run neural networks that they need. And one of the problem, of course, it's transformers that we mentioned earlier. And for transformers, it's super important to have pretty modern NPU chips, because like on some old one, they just completely will not run. And of course, like transformers requires a lot of memory. So you need some chip with a big amount of memory. The second common issue, it's maybe quantization, because with quantization, a lot of neural network actually they drop accuracy, and you should spend a lot of time to maintain this accuracy and to check everything. So you can solve, of course, quantization. You can like retrain model with some additional parameters, but usually it will take like maybe a few months of additional development. And you need to keep in mind like how like your model is quantized, how your like memory is organized, how good is NPU with your specific neural networks. For example, like all these modern VLMs like Qwen neural networks that appeared recently, like DeepSeek and others, they actually can run just on a few devices today. And you need to keep in mind this when you're developing. Of course, like it's also you need maybe look a little bit more on some other parameters of your board. For example, like if you're looking on NVIDIA Jetsons, they have a lot of devices for inference your neural networks. It's not only GPU, it's like DLA unit, for example, and of course you can run something on CPU. And you need like when you thinking about your algorithms, you need to keep in mind that you can like run your algorithms, for example, on Jetson NX on 3 independent devices, which is, in my opinion, also a little bit important. And maybe the last but not least, it's like when you choosing your device, you can check like amount of tops, trillion operations per second for your device. But actually, it doesn't mean nothing today, because you need like to benchmark with your specific neural network on your platform. And these numbers, it's just some reference, maybe like order of magnitude. But in reality, you need to check everything with the devices that you choose.
Okay, so I think what you've described, there is quite a lot of chaos, isn't it? That's what you've actually described. It's almost like A design engineer would be sat there understanding the world that they see and the world that they have experience of. And what you're saying, in a way, is they have to be aware of so much more than just the thing that they see right in front of them, or the knowledge that they have right in front of them, because there is so much more to learn, and because there is so much more to take into context. So if we just explore those three areas in a little bit more detail, and maybe just because of your experience, and this isn't in any way telling everybody that they have to do it your way, and that their way isn't necessarily the right way, because obviously everybody's situation is different. Maybe you could just help express, if you were to like list your, like, definitely start with one and then working your way down, it might end up being 5 things, but just say, if I'm starting a design now in computer or machine vision, I know that I've got memory parameters, I know that I've got language models that I'm going to have to manage, I know that there's other things that are going to be complicated for me. Could you just summarize, if you were as somebody that does what you do every day, what is your logical progression that you work your way through? And then maybe for each one, just give a little description of what's the basis of which you then explore that. Would you mind doing that for us? Just like maybe top 3 or 4
Yeah.
things that for every application you go, right, these are the golden rules. This is what I've learned over the last 18 months. So I know I have to start here and then work my way down the list. Would you just mind sharing that?
Okay. In my opinion, of course, you should start from some product questions, for example, and it's like the main questions. But maybe it's not why you are having me here, because let's discuss more like, of course, algorithms part of this equation.
Anton, feel free to go wherever you want to go with this. Don't be
Okay.
stepped by. This is the whole point of this discussion is for an experienced design engineer who is dealing with problems every day, sharing that and helping other design engineers understand what they understand about the world. Please don't be guided by me. I'm not an active design engineer solving problems every day. You're absolutely the star of the show here. You speak and say how you see it, rather than being guided by me, please.
Okay, thank you. So maybe the good idea is to start from some product perspective. And from product perspective, you just need to check a few things, maybe like, of course, the price of device that you have. And it's like the main limit factor, because if you don't have this restriction, just take maybe NVIDIA Jetsons. They are great. They are like top on performance, and everything will be cool. The second constraint, it's maybe like from the different part, because today's world, it's you can feel borders nowadays. And of course, you can't use like some specific like Huawei boards, they banned all over the world today. And maybe different Chinese boards, they also banned, but they are super efficient in some term, and in terms of like price for the money, they are pretty good. But of course, with them, you can't like maybe create some certified device with fixed environment. And for this, even maybe like Jetsons, they are not. But when we like look from the parts of algorithms, it's, in my opinion, you first should check like this general constraint, like which devices you can use. On the second part, usually when I have some list of alternatives, I try to check for each one of them, like the main neural network I should use. And it's usually not a big work, maybe like a few hours for each device, maybe like 1 day for each device. But definitely, if you have like some list of 5 devices, it's worth to spend this week to check which device is optimal for your neural network, for your inference, and so on. Because like just validating that your architecture is workable, it's pretty important. And like the main issue is usually architecture and quantization. So maybe this is like look first at the product, then you simultaneously trying to look with this constraint on algorithms, and of course on hardware part, where you probably have much more experience, and like to look some limitations from this, like power consumption, from like temperature, and so on. And after this, you will probably have like just one or two devices that are fit for specifically your application. And with them, it's just maybe on this point, you just need to look at the money, at the cost of the process, and decide which one of them is the best one to move forward.
Right. That's very interesting that it's interesting that you started where you started, because we had a couple of discussions at the tail end of last year where we talked about why IoT projects were successful and why they weren't. And the conclusion always came from always start at the money. Always start rather than solve the problem down at the technological point. Always start at what is this product? Where's it going to go? What are the price points for that? Because then you work your way down from there so that you know that you always have a commercial product that's going to be viable at the point that you then solve the technological problem. That message comes over and over and over again whenever we have these discussions. That's very interesting. So I think you've given some kind of outlay about the logical conclusion that you go down to. So you start at what it is that you're making. You start at how much that's going to cost. Then you start looking at the algorithms and the software, and then you start looking at the hardware, and then you start and think about the integration issues. And what you've really stressed there is take your time, make sure that you have actually done that properly. Don't rush. Don't assume that what you've got is definitely going to be the right conclusion for you. And you're saying that might take, with testing, may take up to a week to be absolutely sure that you've got the right combination of all those things. Have I heard that correctly? Would that be a fair summary of what you said?
In general, yes, of course. So, of course, it may be not weak for some specific platform if it's like going to some super small devices and energy efficient. But in general, yes, like these times it may be different. But in general, yes, just verify your business model and then try to check if every requirements will fit for the hardware.
Okay. So I think last question I'd like to ask is, you've seen this massive change. You talked about starting your knowledge and your journey in industrial computer vision 10 years ago, and then we talked about maybe the changes over the last 3 years. I think it's probably an obvious question for me to ask. How do you see the next 18 months? What do you see the challenges for design engineers in this environment? Where do you see potential changes and developments, and for our community to keep an eye out for and to bear in mind when they're starting a project, to ensure that they can obviously never be completely future proof, but as much as they possibly can? What are the things that you think that they should be keeping their eyes out? Where do you see the potential changes and the evolving part of this technology?
I think that right now it's two main interesting points. They are like a bit related with each other, but definitely it's like just a little bit perspective. So the first of all, it's of course VLM models. It's visual language models that can work like simultaneously with visual component, maybe with audio component, and of course with LLM component, and can provide like structured answer and like set of actions for some specific environment. And this is the place where there was a lot of development for last few months, and a lot of companies, if you check like what they will release next, they saying we will support these VLM models, and maybe because of this it's one of the important place. And the second, in my opinion, it's related, same models, but perspective from robotics. Because like for robotics, it's like a lot of movement in this direction. You already maybe so like Tesla bought Optimus, like 1X, and a lot of different robots nowadays. And they have actually the same set of problem, like which device we will put inside, how we will like optimally perform our commands. It's not specifically like VLM's model. It may be set of models, maybe some more complex models, but it's actually the second point of growth today, where, in my opinion, a lot of new stuff arrived each day, and it's just interesting to look and check how it's moving.
Right. So what you're saying is I think what you're saying is where we're seeing these VLMs, you're seeing they're developing every day. They're being used in different applications every day, but you see them migrating over into robotics, and things that people have learned in those other applications, they're going to be able to learn and take into robotics and develop interesting robotic applications in the future.
Yes, maybe I'm more about like where is the main growth today. Like it's
Oh, I see.
just to
Okay.
point. Maybe like it will not lead to anything. Maybe we will just keep the current level of algorithms and will use. But if you want to check where like the everything is developing like most rapidly and most interesting algorithms, most interesting solution, in my opinion, it's this two focal point. Maybe it will not lead to anything, but at least it will be interesting.
Very good, very good. Well, Anton, I think that concludes our chat. You've been an absolute pleasure to have on our ipXperience. This has been we're going to do more of this kind of thing where we take people like you who are incredibly knowledgeable, very experienced, understand the industry they're in, understand the challenges that they're facing every day, and helping give insight to our community, some of the challenges that they see and some of the ways that they solve them. So thank you very much for your time on our ipXperience today. And maybe we'll have an update from you, Anton, in 6 months' time and see how things have changed, because things do seem to change extremely quickly in this world that we're in. And we will look forward to hearing from you then. Thank you very much.
Thank you for having me. Thank you.